Okay, so now we're clear of the car club box of sets. We get onto the normal schedule of repairs, and we've got a Harrier CBHQ base station. So those of you with repairs in, you will have normally been given a job sequence number. So this is job sequence number 1, because we've reset after that set of 7 or 9 or whatever it was radios from the Bury St Edmunds car club, not Bury Lancashire as I first assumed. I'd love to get some of these big screws. I've got my base station doesn't have these. They're missing. I suppose we could just get screws with washers, but they're kind of M4 but oversized. So this is going to the power supply capacitor is doing, simply because of the age. Now he's bought this from a reputable supplier of mainly amateur radio equipment, but at the end of the day they don't go inside and do service work, they just sell stuff. And he said one of the issues is it's got the wrong speaker. We should be able to sort that out, especially if I can find his letter. That comes with the original mic. Looking for a full tune-up, tune the VCO, power, frequency, etc., and check the capacitors. As mentioned, the speaker is not the original, so if you can replace that. He says with the original one. Well, I can't replace it with an original one, but I can replace it with a suitable replacement. He's got tone high and low and power high and low issues, so hopefully he's done a bit of switch cleaner on that, and hopefully that works. And he is in Tyne and Wear. So if you look underneath, and we'll be having to have the bottom off, it's really nice condition. Right, yeah, it's got a 4 ohm speaker in, which looks like it's out of a telly, and that will not have helped the amplifier at all. So before I'm going to switch it on, we're going to change the power supply capacitors, because I just don't want to risk things going pop. So I'm going to unscrew this lid. So it's in nice condition underneath too, so we'll just get on with these supply capacitors. Quick look back the other way, and there's no visual, nothing's overheated and got ruined. You know, the capacitors haven't got their heat shrink tubing retracting. So doing this precautionary, because at 40 years old, that is asking for trouble. And what we don't want is for the power supply. I don't know whether for the people of you who don't know how these power supplies basically work, is you've got a transformer turning the AC mains 230 volts in the UK, in this for example, into usually somewhere around 26 volts. So mains goes in, 26 volts goes out. Because it's using a transformer, it's isolated, which is ideal. That's how it should be. That 26 volts AC gets rectified with the 4 rectifier diodes, and then there's a capacitor there to add smoothing, because you get ripple with the bit of AC still coming through. And then you have some electronics here which stabilizes the voltage regardless of what current you use, whether it's 300 milliamps or whether it's 1.5 amps, which is probably about the absolute maximum when it's on transmit. And it keeps that voltage more or less constant, which is going to be somewhere around 13.2 to 13.8 volts using the trimmer resistor there, variable resistor. So if this capacitor went wrong and any of these transistors got destroyed because of dodgy capacitors, you can end up with a power supply like this giving you the full 26 volts into the radio, which of course we drew in the radio, and that's why we take the precaution of changing the capacitors in the power supply, because we want everything possible for it not to pass 26 volts. Now modern power supplies which are using switch mode techniques, they aren't as well isolated from the mains, and you can end up with those blowing up and passing mains voltage through the products, which is one of the reasons I don't like switch mode power supplies. Anyway, enough waffle. My soldering iron should have warmed up. I'll get those capacitors out and changed. Right, so that's those two done. 2200 microfarads. We've put much more volts in, 63 volts. One of the reasons it's a little bit smaller, but this is 25 volts that's come out, and I really think it needs to be 30 something. The reason we put 63 in is the physical size, because over the 40 years the size has come down, and for that to fit in the holes provided, we're putting a bigger voltage in. It's a sensible thing to do so that it's not flopping about. The same applies with that. That's a higher temperature rating and a higher voltage. I just think it is in a position where it can get warm, so that's 105 degree rated instead of 85 degree rated. So we'll switch on. It is lit up. We have a meter lamp. It's on channel 20, and we need to just make sure this power supply is set somewhere sensible, like 13.2 volts. So I think that's negative. And where shall positive be, shall we think? Is it that link? No, that's the transformer. Is it that? No, that's the transformer too. Is it there? Yeah, I would think that's probably about it. 12.41. Really, that's too low to be sensible. So we will be now having more. I'll use our microphone initially. That's not the right one. We'll use the standard Cybernet microphone rather than the customer's microphone. I'm going to key up. We'll put picture in picture on. I'll key up with the power supply at the 12.4 volts. Let's just connect the aerial. So we'll key up. I'm on the 3 watt scale. It does 3 watts. So we'll go over to the scale. So we're just on 3 watts. So I'm going to put the power supply up to a sensible level, and we'll start at 13.2 rather than 13.8. Now where did I find that positive connection there? Oh no, we used the one there. These aren't easy to get to. So 13.26 seems a sensible starting place as far as I'm concerned. Let's see what the power's now doing. So it's come up to 3.5 watts, and that's going to be the difference between a tired power supply and not. So we'll go over to the VCO. So it's channel 40 on these sets. I did one yesterday because I was doing that Rotel for the car club customer. So test point 1, resistor 4, so that's a bit high, it's a lot high. Should be 4 volts. If you don't get this right, channels are going to drop out at either end. So that'll do me for 4 volts. And then I'm going to transmit. It should also be 4 volts. So a little bit out. It's the red trimmer this time. If this has been a smoking household, they need replacing. The nicotine wrecks them. So back to receive, 4 volts, back into transmit, 4.1. So now select channel 1. We're supposed to be still being transmit, and it's supposed to be 1.8 to 2.5 volts, which it is, and in receive it's supposed to be 1.9 to 2.5 volts, which it is. So that's the VCO set. So that's great. I'm glad I looked at that, because that was further out than I would expect. So remembering to put the set back to channel 20, let's just look at where the deviation is. I'll get a piece of paper and we'll write these things down. So transmit was 3 watts. Now what it was like before I did the power supply, I don't know, and I didn't want to risk damaging the radio in testing it. So we haven't done that yet. Deviation, let's have a quick look. Wallow, it's deviation equals 2. Just needs to come up a little bit, that's alright. Frequency, let's go over to the camera. 2779112, it's virtually spot on. I'll just do that now with the trimmer capacitor there. But that was nearly spot on. That really didn't need doing. It is now even more spot on because it dropped with age, so it's a sensible thing to do. And the meter is just about on the 5 on the thing on the front, on the meter on the front. Right, we'll just go into the transmitter tune-up. So 3.5 watts. Just check that's right. That's correct. That's correct. A little bit on that one. And then the other 3, this is the critical sequence. Wherever my expensive set of trimmer tools goes on. So, maximum. It's not the right end. It's not the right tool. Is it that one? That brings it to 4.05. That brings it to 4.4. And that brings it to 4.6. Go through them again for maximum. And then we follow the instructions to balance this, which I can't ever remember. So it's L4, L8, L9. L4 is clockwise for 4.4 watts. So it's 4.6, so clockwise to 4.4. And then L9 anti-clockwise, and they say to 3.8, but we're doing it to 4 watts because that's what you're entitled to in this country and most other countries. 3.8 so they can get through the customs without them sending the container load back. So that's now doing a full 4 watts, and then we check that on channel 1 and 40 it's somewhere like, it's preferable if it's within 0.1 of a watt. So on channel 1 it's 4.0 something, on channel 40 it's 4.0 something, and then back to channel 20 it's now 4 watts on the dot. So that is a great result. So far so good, this is working nicely. So deviation, well, I want that. It's a funny arrangement. You've kind of got mic gain and a feedback circuit, and I want that in the central position, which it now is. And then with our little oscillator, we'll now look at the deviation. That needs to come up. Wallow, that's now spot on. So the way it was, it would be a bit funny the way he talked, the way it wouldn't be normal. So it's 2.2 to 2.5 kilohertz, and that's now from 3 watts to 4 watts. So that's done those basic transmit things, and probably take longer to do the speaker on this than the whole rest of the set. So the transmit meter is this preset here. So into transmit, and that needs to read about the 4, so between 3 and 5. Remember, these meters are only relative power meters. We've got a dummy load in the test set. If I put it on an aerial, it might only read 1, it might bang across. Doesn't mean that you're only giving out 1. It's still the same radio, it's still the same power, just the way the meter reads. Probably this is why in modern sets it's pre-programmed just to read something, and it doesn't matter how many watts the radio is giving out, whether it's 100 milliwatts or 4 watts, these pre-programmed meters still give you the same number of bars. So we have now covered the transmitter, that's working fine. So let's go over to receive. For a start, I'll need to plug the extension speaker in, which connects up to our test gear. So now we want 2779125 channel 20 on this frequency on the signal generator. So now we have 2779125 on the signal generator. Turn the volume up. And let's look at the synad meter and see what the radio is actually doing without any intervention from me. These have an extra circuit that the mobiles, the cheaper mobiles, don't have. But they have 2 extra circuits that they receive. The very cheapest Cybernet 134 mobiles don't have. Here goes. So let's get 12 dB on the synad meter and read that up on the attenuator controls. 1, 4, it's 4.5. So it's 0.45 microvolts for 12 dB synad. Now the best of the best of the best of these will do 0.27, and the worst of the worst of the worst will do 0.9. So this is already beyond the manufacturer's specification, which I recall is about 0.5. So this works very well already. Now, first thing we're going to do is not put that on, but put that on. We want S9 equivalent signal, which is 100 microvolts for a CB in the UK. And we want to adjust the detector for maximum recovered audio. Now this can make a huge difference if it's wrong. You know what, it was a little tiny bit out. I just hope by the time the customer gets it back in the post, that it's still right. There we go. So that's maximum recovered audio. So that will have made a difference to how the clarity is, not the sensitivity. So go back to synod meter, and we'll drop down till we get about 4 dB on the meter, so we're not saturating the receiver. Start with the front end. And there's a very slight improvement there. We'll drop it back down to 4. Now we're going to put a bigger signal onto these. To be honest, nothing else seemed to be out apart from this first one. There we go. So let's get a new reading. So now for 12, it's 0.43. There you go. So it was already spot on. We will have improved the clarity because of that detector. So we're now listening to 0.3 of a microvolt, 0.25, 0.2, 0.15. So you can hear down to 0.2. Have I got RF gain up? Not quite. Let's take that reading again, just in case. So, synod. Yeah, it's 0.44. It's just the same. And the tone's in the high position and delta tune's in 0. Yep. Good. So I've been through that. So now we want to look at the meter. So S9. Take that off. And it's just about spot on S9. That is a little bit low. There we go. And then finally squelch. So I'm going to turn the squelch to full. I'll put the speech-in-picture back on, this time showing the attenuator controls. So, attenuator controls, we're at 0.3. So when this gets to 100 microvolts, I want the squelch to open. I'll put it on full squelch. Let's see. 1 microvolt, 3 microvolts, 10, 30, 100 it comes in. So that's exactly where it wants to be. So it doesn't need adjusting. If it did need adjusting, it's the preset just there. So now at the sensitive end of the radio, we'll switch the signal generator to standby, set the squelch to threshold, and the signal generator is parked at 0.3 of a microvolt. So switch the signal generator on. Let's see when it comes in. About 0.95 microvolts, and it's off at 0.9. So that's going to be quite adequate. There are sets with better squelchers, but they are quite adequate on these sets. So he's got one or two things he wants me to look at. Tone high and low. So really it's just a matter of switch cleaner on these kind of things, if we can get into them. I'll turn the radio off. And we use the service all. I don't think I've checked low power on this. Right, switch back on. We'll start with putting the radio into low power, because I forgot all about that. So on high, here we go. Unplug this extension speaker. So in high power it's doing the 4 watts. In low power it's doing 10 milliwatts. See whether we can adjust that. There we are, 400 milliwatts, which is where it should be. So back to high power, back to low power. Fine. So that's working. Channel 9, that works. Now it's tone high and low. That seems fine. So between his squirt and my squirt, we seem to have fixed that. So it just leaves us with this speaker situation. So I've got no alternative but to take the front off the radio. So I'll leave the video and we'll take the radio apart. So we find that this monocoil SP3 RDP seems to fit quite a few CB radios. Not always available in the quantities we would like. You'll see from the footprint, you can see where the previous one's been, and that fits absolutely exactly. But of course the hardware's gone astray, hasn't it? So we'll have to put some washers in. So what I've just done is to make out of 18 gauge phosphor bronze wire this clip. So hopefully that's going to fit in the holes supplied and bushed into for the speaker. I couldn't do this really with a mobile because it would stick down slightly, and there's more room in the base station to do this. But it's really frustrating when somebody's not included the hardware with the radio. You know, if they're going to do this, take out the mounting hardware and shove it in a bag and give it the next customer, or even put it inside the radio in a bag. But no, they don't, and we end up having to. Not everybody's got the facilities. As an organ builder, I can do things like this, but not everybody can. So we have 18 gauge phosphor bronze wire in stock. So let's give it a go. Right, so we've done that, just about. So the phosphor bronze clip, you can see goes from there to there, and the reverse side, so that's sprung in I mean, it may have been an arrangement like that, I don't know, I've never really looked at them before. Make sure the terminals are in the clear position, so that's why we've done 3 and not gone round 4. But the only M3 bolts that we have in the RS kit there, they jump from 6mm to 20. So the problem there is that the bolts are going to poke out. Well, that's no good. We need to cut those off. And the trouble is, if you cut them off, you wreck the thread. So what we're going to do is cut them off with, if I can cut them off with the big pliers, that would be useful. You know what? I can't cut them off with the big pliers. I'm going to have to go across to the organ workshop and get a hacksaw. Plan B actually is to use an angle grinder, and we should have a little one here which we use for cutting aerial whips for business radios. So hopefully I'll be able to get that in. So I'll repeat that on the others. Better put that back before Mr. Chippy notices. He's the custodian of all these kind of things. So the next thing, cutting the excess length off. I'm just going to move this camera forwards. Now I've put some nuts on here so that I can wind these nuts off and restore the threads which will have been somewhat damaged. That's come off all right. And that's come off all right. It's this one that's going to be the swine. I haven't even got the right pliers on this bench. I certainly don't have spanners. So these nuts have just been put on by me just so I could do that and for no other reason. So I'll put those back in the box. We don't need to sell them to the customer. And they're now through, and if it ever had to be removed, they're going to come out properly because the integrity of the threads is there. So hopefully the lid will go back on, or even the front. But in the meantime, I'd better solder on the connections. Right, so there we go, finished and wired up. So hopefully we'll put the front on. And that fits on comfortably. Right, I'll just turn it on. Are we plugged in? Just need to make sure it's actually working. And while we're at it, we'll plug in the customer's own mic. Yep. Right, I'll pause the video and screw the radio back together. Right, so there we are, done. So it's back together, lids are on, immaculate underneath. We'll have a flick round as usual. One and a Roger. Nineteen a Roger. Right, well, we'll leave it at that. Just can't quite tell what he says. Well, I think they're taking a bit of controversial stuff there in a controversial way. So we'll go, we'll do a on-the-air test later on, and that can go back to the customer. So I think that's a good outcome, and no one would ever know that that fitting arrangement isn't factory or that speaker. Thanks for watching the Harrier CBHQ base station from 1981, at which time they, if I recall, they were either £129.99 or £149.99.